Today, we're going to talk about quadratic scenarios. This is the last lesson for quadratic graphs. Next week, we're going to look a little more at the equations of quadratics. So, regardless of whatever application you have, which the most common applications are an object is in flight, or the area of some object, some surface, the profit of some scenario. Regardless of whatever application you have, you're going to be asked questions about one of the key features that you've learned, which is y-intercept, roots, which are x-intercepts, the vertices, or just any coordinate. So here are some ways that you can successfully answer these types of questions. All right, so in this scenario, it says, all right, so there's this rocket in flight, and it is modeled by the function y equals negative 16x squared plus 149x plus 108. So we can ask a bunch of questions from this. First thing I want you to notice, though, is the graph. It's kind of a misleading graph. It looks like just a vertical line, slightly tilted, almost a slope, almost an undefined slope. So the first thing that I would want you guys to do is to be able to zoom out so that you can actually see a parabola. If you can see a parabola, then you've zoomed out enough. So I can tell now the second x-intercept is about 10, all right, almost 10. And if I continue zooming out, I'll find the vertex of this one at 4.6. So what I'm going to want to do, and we don't usually do this, but I'm going to go to the graph settings, and I'm going to change some of these settings. All right, so my x-axis, I don't need it to go from negative 800 to positive 800. Instead, I'm going to change it to go from 0 to 15. You notice that the second x-intercept was 10. So I'm going to have it go from 0 to 15. And that in itself is enough for me to fix this graph to where I have a good quadratic function. All right, because I have now narrowed it down to, let me look at the intercepts. So here's some questions that we could answer now. Question number one, what's the highest that this rocket goes? Well, now that you see this shape, you can probably predict that the highest that the rocket is going to go is right there at the vertex. So any question of what is the minimum, what is the maximum, what's the highest or lowest refers to the vertex. In this case, the rocket is going to go 454.891 feet in the air. That's the highest it's ever going to reach. So by highest, we mean the highest output. Okay. It could ask you also, at what time does it reach its highest output? And you can say 4.656 seconds. All right. Remember, your input is time and your output is feet. Okay. Number two, after how many seconds is it going to come back down to the ground? Well, we just answered that. It's rising all the way to 4.6 seconds or 4.7, and then it's starting to come back down. So that answers that question. I can also, I can trace this graph and I can find all these coordinates. All right, if I just click on the graph. Question three, what does the point 0, 108 represent? Well, 0, 108, so I know that's the y-intercept, but now I want to interpret it in context. In context, well, I see it in the equation 108. Well, I want to think 0 is what unit and 108 is what unit? Well, the input is time, so that means 0 seconds, and 108 is an output in feet. So that means 108 feet, which means at 0 seconds, the rocket is at 108 feet. In other words, it was launched at an initial height of 108 feet. All right. Number four, how high is this rocket after 5 seconds? So I can do this a number of ways. I can trace this all the way to 5, right? And I can try, if I can get it exactly at 5, then I'll have the exact answer. There we go. 453 feet in the air after 5 seconds. Another way that I can do that, because sometimes it's harder to trace than others, is I can turn my equation into a table. All right. And turning it into a table gives me a lot of different values. All right. So I can click more in my table. I can enter more values, and there I have it. The point 5, 453. Okay. So that gives me a lot of information. And one thing that I like to do with my tables is I like to be able to see a sign change. So I can see right here that I have negative values, then positive values. I can click all the way until I get another negative value, which leads me to the last question. You could ask also, when's the object going to hit the ground? You can say at about 10 seconds. Well, really right here, it tells you at 9.98. So there's a lot of questions about the zeros, the roots, the intercepts, which you could answer as well. Also, you can answer questions about the outputs.